Hey guys, welcome to Safi Mixed. In this video, I will let you know how to derive the distance formula in coordinates, in Cartesian coordinates system. To this end, I first construct the Cartesian coordinates in a plane that is first I draw a horizontal line and then a vertical line, and I represent the horizontal line with coordinate x and the vertical line with coordinate y. Then I choose a point in this plane and I represent this point with P. To assign coordinates to point P, I drop a perpendicular line on the x-axis and I represent this position with x1. And similarly, dropping a perpendicular line on the y-axis, I represent this point with y1. Then the coordinates of point P are x1 and y1, and I write that like this. That is, P is a point whose coordinates in the Cartesian coordinates plane is given by x1, y1. Then I take another point and I represent this point with Q, and I do the same thing. That is, I drop a perpendicular on the x-axis and I represent this point with x2, and dropping a perpendicular on the y-axis, I represent this point with y2. That is, the coordinates of point Q are x2 and y2. And I write point Q like this, so which says that point Q on the xy plane is a point whose value along x-axis is x2 and along y-axis is y2. Then the separation between x1 and x2 I write as delta x and is written as x2 minus x1. And similarly, the separation between y2 and y1 is written as delta y, which is equal to y2 minus y1. Now, let us draw a horizontal line from point P whose length is exactly equal to the length between x1 and x2. That is, I drag a line from x1, x2 like this, and I represent this point with R. Then the separation between point P and R is exactly equal to the separation between x1 and x2, as you see, because x1 and x2 and PR are the separation between these two parallel lines. The same I do with the separation between y2 and y1. That is, I take a line parallel to y2, y1, and I place it between Q and R. Now, if I join point P to point Q, I have a distance which I represent here with red line. And what you see here, PRQ is in fact a right angle triangle. Therefore, I can apply Pythagorean theorem to this figure. And according to the geometry, PQ is the hypotenuse and PR is base of this right triangle and RQ is perpendicular of this right triangle. And according to Pythagorean theorem, the square of the hypotenuse equals the square of the base plus the square of the perpendicular. That is, I can write PQ squared plus PR squared, that is P to R, this distance, plus the distance from R to Q. So I write that as RQ squared. Now, P to R distance is exactly equal to delta X, and R to Q, that is this to this distance, is exactly equal to delta Y. Therefore, I replace these values. That is, I write PR equal to delta X, so PR squared delta X squared, and P and RQ squared equals delta Y squared. Now, in terms of the coordinates, I can replace delta x with x2 minus x1 and delta y with y2 minus y1. Doing that, I can rewrite this relation as x2 minus x1 squared plus y2 minus y1 squared. So we have pq squared equals this thing. And if I take the square root of this whole equation, I can write distance PQ equals square root x2 minus x1 squared plus y2 minus y1 squared. This formula gives the distance from point P to Q in terms of the coordinates x1, x2, and y1 and y2. And this is what we call the distance formula. So the distance formula in the Cartesian coordinate system can be derived by using the Pythagorean theorem. If you haven't yet subscribed to Safi Mixed, kindly support the channel by pressing the subscribe button and also hit the like button on the video. Thanks for watching.